Hi everyone, welcome to trigonometry. Today we explore lesson 2, the unit circle. Number 1, the unit circle. It is the circle of radius 1, center at origin. We will use the unit circle to define sine, cosine, tangent because it gives us a quick computation of some common angle. Let's take a look at the right triangle inside a unit circle. The radius is 1. We'll have x on the adjacent side and y on the opposite side. From here, you see that sine of the angle theta is opposite over hypotenuse. Y over 1, which is y. Cosine of the angle is adjacent over hypotenuse. X over 1, which is x, and tangent of the angle theta is opposite over adjacent, y over x, at the angle theta equal to 0. What we see here is that x equal to 1, y equal to 0. And then from here, we have sine of 0 is 0. Cosine of 0 is 1. Very cool, huh? At the angle theta equal to pi over 2. X equal to 0, y equal 1. So we have sine of pi over 2 is 1. Cosine of pi over 2 is 0. The angle theta is equal to pi. So it's right here. You can see that the point here, x equal to -1, y equal to 0. So that means sine of pi is 0. Cosine of pi is -1. We can use the unit circle to figure out sine, cosine of 0, pi over 2, pi, 3 pi over 2, and 2 pi. What about the other angles? Exercise 1. Find sine of pi over 4 and cosine of pi over 4. Let's take a look. Pi over 4 is halfway between 0 and pi over 2. This angle is pi over 4 or 45 degrees. Here we made a right triangle. Using the unit circle, then this 1 xx. If one angle is 45 degrees, then the other angle is also 45 degrees because the sum of all the angle is 180 degrees. Sum of angles inside a triangle is 180 degrees. Next is there's the property of 45, 45, 90 degrees. And that is y equal x. 45, 45, 90 degrees. Is that adjacent is always equal to opposite. Which is why you see that I wrote xx instead of xy. From this property, then we can figure out x. Well, this is the right triangle, so we're going to use the Pythagorean theorem. X squared plus x squared equal 1 squared. 2x squared equal 1. X squared is 1 over 2. Hey, what's that? X is root 1 over 2, which is 1 over root 2 multiplied by root 2 over root 2. Rationalize it. And we have root 2 over 2. And because x is root 2 over 2, now we can define sine and cosine. We can actually get tangent if we want to. Sine of pi over 4, that is x, which is root 2 over 2. Cosine of pi over 4 is also x, which is root 2 over 2. Very cool. Let's take a look at another example. So in this example, we're going to figure out sine of pi over 6 and cosine of pi over 6. Pi over 6 is 30 degrees. This is the right triangle. Well, if that side is 30 degrees, then this one is 60 degrees. We can draw another right triangle down here. This is also pi over 6, and that is 60 degrees. This is an equilateral, and it has a cool property of equilateral. 60 degree, 60 degree, 60 degree. Each side 60. So meaning that same side, exact, same length on each side. Well, because we use the unit circle, the radius is 1, so that is 1. And this whole thing right here is also 1, which means that this side right here is y is half of 1, which is half. And we just have to figure out x. We can find x using the Pythagorean theorem. X squared plus y squared is 1 squared. So x squared plus 1 over 2 squared equal 1. X squared plus 1/4 equal 1. X squared is 1 minus 1/4, 3/4. X is root 3/4, which is root 3 over 2. Once we have x, then we can define sine and cosine pi over 6. Sine of pi over 6 is y, which is 1 over 2. Cosine of pi over 6 is x, which is root 3 over 2. Oh, we can also define sine and cosine of 60 degree from the triangle. Sine of 60 degree is pi over 3. Its opposite is x, so that would be root 3 over 2 cosine of pi over 3. Adjacent is y, 1 over 2. Look at this there. Sine of pi over 6 is cosine pi over 3, and cosine pi over 6 is sine pi over 3. From here, well, you see that, there's got to be an identity here. And the identity here is sine of the angle theta is cosine pi over 2 minus the angle theta. And cosine of the angle theta is sine pi over 2 minus the angle theta. Table for common angle and some trig values. Okay, so we have 3 common angle: 30 degree, which is pi over 6, 45 degree, pi 4, 60 degree, pi over 3. Sine pi over 6 is 1 over 2. Sine pi over 4 is root 2 over 2. Sine pi over 3 is root 3 over 2. And then because we know cosine of the angle is sine of pi over 2 minus the angle. Well, we just have to reverse the order. Cosine of pi over 6 is sine of pi over 3. And we get root 3 over 2, root 2 over 2, 1 over 2. Very cool, huh? Tangent is sine over cosine. So 1 over root 3, or you can rationalize it to get root 3 over 3, 1, and root 3. Pretty cool table. Well, another cool thing is that the angle can be in any of the 4th quadrant, depending on the corresponding right triangle. We can either have a plus or minus in front of the value. So here come some example. If the angle is in the 1st quadrant, right, then we know that the opposite and adjacent, they are positive. Then from here, sine is positive, cosine is positive. However, when the corresponding right triangle is in the 2nd quadrant, then opposite is positive, adjacent is negative. And then from here, we see that sine is positive, cosine is negative. And similarly, using this right triangle, in quadrant 3, both opposite and adjacent is negative. So sine is negative, cosine is negative, And in the last quadrant, only the opposite is negative. Sine is negative, cosine is positive. Pretty cool. There is an identity that we can get from taking a look at the value of the angle in the quadrant. You see that in quadrant 1, if you do the comparison between quadrant 1 and quadrant 4, sine of negative of the angle theta, that is the angle below the x-axis, is it's the negative value. So what we have is more identity. Sine of negative angle is negative sine of the angle. Then cosine of the negative angle is, well, it's just the positive. So it's the same as cosine of the angle theta. This is the pretty cool identity. It's the negative angle identity. Let's take a look at some example. Example 1, find the value of sine 2 pi over 3. Let's do some sketch here. Two pi over 3 is in the second quadrant. 2 pi over 3. The corresponding right triangle is this one. And the angle right here is pi over 3. In the second quadrant, sine is, well, you can see positive. So it is the same as positive sine of pi over 3, which is root 3 over 2. In B, we have cosine of 5 pi over 4. 5 pi over 4 is in the third quadrant. It's right here. The corresponding right triangle is this one. The angle right here is pi over 4. So in the third quadrant, adjacent and opposite, they are negative, meaning that the value of cosine is negative. Negative cosine of pi 4. And we know cosine pi over 4 is root 2 over 2, so negative root 2 over 2. Tangent of 11 pi over 6. 11 pi over 6 is close to 2 pi. It's in the fourth quadrant. This is 11 pi over 6. The corresponding right triangle is this one. This angle is pi over 6. Well, in the fourth quadrant, adjacent is positive, but opposite is negative. What this means is tangent of 11 pi over 6 is negative of tangent pi over 6. So that'll be minus, well, we know tangent of pi over 6, which is root 3 over 3. Example 2, given tangent of the angle theta equal negative 3 over 5 in quadrant 4, sketch the angle theta, the corresponding right triangle, and find the values of the remaining 5 trigonometric functions. Let's sketch the angle theta here. First, it's in the fourth quadrant. Something like this. That is the angle theta. We have the corresponding right triangle. This angle right here is theta bar. Tangent of theta is negative 3 over 5. What this tells us is, well, negative 3 is opposite, 5 is adjacent. C square is 5 square plus minus 3 square. C square is 25 plus 9. C square is 34. So C is root of 34. Okay, we have C. Well, from here, we can figure out the 5 remaining trig function. Okay, so here come sine of the angle theta is the same as sine of the reference angle theta bar, and according to the right triangle, that would be negative 3 over root of 34. Cosine of the angle theta is cosine of the reference angle, and that is 5 over root of 34. Cotangent of the angle theta is 1 over tangent of the angle theta, which is negative 5 over 3. You just have to flip the fraction. Cosecant of the angle theta is 1 over sine of the angle theta, which is root of 34 over negative 3. Then I would put a negative in front of the fraction. So negative root of 34 over 3. Secant of the angle theta is 1 over cosine of the angle theta, which is root of 34 over 5. Yay! We got all the values. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel growth. I will see you in the next video.